An algebra student who shows up to a test without a full factoring toolbox is like a plumber arriving at a construction site without his pipe wrench. Sure, you might still crawl under the sink and bang on some pipes, but you're not fixing anything. Factoring isn't just some niche skill, it shows up everywhere. Solving quadratic equations? Factoring. Simplifying rational expressions? Factoring. Finding intercepts? Factoring. In calculus, it's how you break down limits, simplify derivatives, and locate critical numbers. Skip it, and you'll be staring at unsimplified expressions like a plumber staring at a leak, muttering, "Without my pipe wrench, I might as well have stayed home and watched Netflix." Determining the GCF is like making a playlist for a family road trip. We only include tracks that appear in everyone's personal playlist. And think of the exponent as the volume. If track X is universally loved, but Dad blasts it at volume 100 and Mom can only handle volume 25, then for everyone's sanity, X to the 25 goes on the trip playlist. That's how GCF works. Only the shared tracks, and only at the lowest volume that keeps the whole family from jumping out of the van. Factoring by grouping is like algebraic speed dating. You pair up terms and look for chemistry, namely common factors, and if it works out, they show up to the next round holding hands. That would be a common binomial. These are friendly trinomials, like puzzles with corner pieces already in place. What is the best strategy if C is rather large? Like the second example. List all pairs of factors that multiply to C, then pick the one pair that also add to B. And yes, sometimes the right pair is at the bottom of the list, just to test your emotional stability. These are trinomials with complex trust issues and profound childhood traumas. They take a little more work to open up. Perfect square trinomials are those students who show up early, sit in the front row, and color-code their notes. Their structure is so tidy it almost feels suspicious. To spot one, look for a perfect square at the beginning and end, and check if the middle term is twice the product of their square roots. Memorizing perfect squares up to 15 is one of the smartest things you can do, not just for math tests, but also because nothing cries dateable genius like casually factoring perfect square trinomials before your crush even finishes writing it down. It's not clear at first why mathematicians called A plus B and A minus B conjugates, but it comes from the Latin for joined together. They're like algebraic spouses with opposing personalities. They have the same terms, but one always flips the sign just to be different. When you multiply them, the middle terms cancel and you get the clean, beautiful result A squared minus B squared. It's like they were destined to be together. Not to stay married, but to eliminate each other's issues and walk away as a difference of squares. Memorizing perfect cubes is like training your brain for algebraic face recognition. If you don't recognize that 27 is 3 to 3 or 125 is 5 to 3, you might stare at a polynomial for 5 minutes wondering if you know it, and miss your chance to factor. It's like bumping into someone at a party who clearly knows your name, your dog's name, and your high school GPA, and all you can say is, "Hey, what's up?" Don't let that happen with polynomials. Know your cubes, at least to 5, and greet them confidently. Factoring completely means you don't stop at the first layer. You begin with the GCF, then check for patterns like trinomials, difference of squares, or even sum or difference of cubes. It's like peeling an algebraic onion. Tiers are optional. Not every trinomial wants to be factored. Sometimes they just want to be left alone. Respect their space. Legend has it that the night before defending his PhD in advanced factoring, young Isaac Factorton had a powerful dream. In it, he was visited by a radiant mathematical angel named Excellenta Divinatus, the eternal guardian of algebraic virtue. Hovering above a cloud shaped like a Venn diagram, she spoke in perfectly simplified expressions and bestowed upon him the 10 commandments of algebraic practice. Among them were sacred decrees like, "Thou shalt not divide by zero," "Thou shalt not cancel terms, only factors," and "Thou shalt not round until the final answer." But the most relevant commandment to that particular night was, "Thou shalt always factor completely." From that day forward, Factorton vowed to uphold that law. He passed his defense with flying colors, corrected his advisor's sign error mid-presentation, and became the knight we still quote today.